So this is for calculus. We're looking at assignment 4-2B. That's our section. Problem number 63. And so this problem is asking us to use the midpoint rule, and they give us this crazy looking thing here to approximate the area of n equals 4. So what this whole giant formula is really doing is it's really saying that if n is 4, we have 4 rectangles. We're adding the area of 4 rectangles under a curve. And this part right here is going to give our height. It's going to be our y values. It says f of something. So those are our y values or our height. Remember, we're adding a bunch of rectangles. And then this delta x part is going to be the width of those rectangles. So I'm going to draw a little picture of what's going on here for our first problem. So if we are looking at this function x squared plus 3, so we know x squared plus 3 looks something like that. I know it's horribly not to scale. And we're looking at this interval from 0 to 2. And we want there to be 4 rectangles. That's what n equals 4 means. So I'm going to go through and I'm going to divide this into fourths. So I would have 1/2. This would be 1 1/2 or 3/2. So now what they're saying for this midpoint rule, if I think about what's going on here, x sub I plus x sub I minus 1 over 2. Like, what the heck is that? Well, I know when I add two things together and I divide by 2, I'm really finding the midpoint. So like my xi would be this 1/2 right here, plus my xi minus 1, that would be the term that comes before that. That would be the 0. And I'm dividing by 2. So what it's really guiding me to do is it's helping me to find the midpoint. So when I go through and look at these rectangles and kind of sketch them out, it's going to be hard to see on this first one, but I'm not connecting to the left or to the right. I am connecting to the midpoint when I draw them out. So it's like a different way. Instead of doing, I guess it'd be down here. Instead of looking at left or right, we are looking at the midpoint for our height. So that's kind of a little picture of what I'm doing. So if we were going to go through and show this with math, do these parts right here with math when I'm finding my delta x, I would say, oh, delta x, that's going to be the width of each of these rectangles. I know that the whole thing goes from 2 to 0. So my whole distance along this x-axis is going to be 2 minus 0. And then I have to divide that into 4 parts because n equals 4. And there's a formula for this somewhere, but I think understanding how we're getting it makes more sense. And you get 1/2, which we already knew, right? We went through and we split from 0 to 2 into 4 parts. We got 1/2. And then this over here is saying my first one is, so this would be like my I is 1/2. So x, so that would be 1/2 plus the one that comes before that, because that's what this means, right? I minus 1 would mean the term before that is 0 all over 2. So my first midpoint should be 1/4. Well, I already know that halfway between 0 and 1 is 1/4. So when I am looking at this point right here, if I'm looking at the height, it's going to be 1/4 comma, the height is going to be f of 1/4. If I want to do the next one, I would write 1 plus 1/2 over 2. Well, that's going to be 3/2 divided by 2, which is going to be 3/4. And obviously, I know that again, halfway between these two would be 3/4. So I'm looking at this x value being 3/4 and the y value being f of 3/4. So all this is having us do for this summation is it's saying add all of those rectangles together. So it's just a really fancy way of looking at the math that we were doing. So if you used this formula, what we would be doing is we'd be doing f of 1/4 times 1/2. And I need to have parentheses here. I don't really like the way I wrote this. Let's rewrite this. I'd have f of 1/4 times 1/2 plus I'd have f of 3/4 times 1/2. What would be the next one? Halfway between 1 and 1.5 would be 1 1/4 or 5/4. We'd have f of 5/4 times 1/2. And I wouldn't write it down this way at all. I think it's super ugly. Halfway between, let's see, this is 6/4. This would be 8/4. This would be f of 7/4 times 1/2. So the way we've been writing this out is we've been writing that 1/2 over here and then brackets and then just adding up all the y values. So to get the y value, I have to actually plug this into my formula. So my formula was x squared plus 3. So I'm going to have 1/4 squared plus 3, and then I'm going to have 3/4 squared plus 3, and then I'm going to have 5/4 squared plus 3, and I should not have made my brackets until I was done because I still need to add 7/4 squared plus 3. So we are doing the same thing, except instead of looking at a left endpoint or a right endpoint or an upper or lower sum, we're looking at a midpoint instead. So this is all in that quest to see what is more accurate, right? Like that's what we're really trying to do. We're trying to make these estimates for our area really, really accurate. So when I go through and do all my squaring, I'm going to do that first. They're going to work out nicely. They're all going to be 16ths, so I'll be able to add them together. 1/16 plus 3 plus 9/16 plus 3. So I've got to square the top and bottom on those fractions. 25/16 plus 3 and 49/16 plus 3. So I've got some 3's I can add up. That's going to be a 12. I'll go ahead and start with that. And then all my 16ths I can add. So 1 and 9. Actually, let's do 1 and 49. That's going to be 50. And these would be 34. So 50 and 34 is 84/16. Let me go ahead and move my paper up here. So then I want to reduce this by dividing the top and bottom by 4. So 12 plus 21/4. Let's see. I probably want to add them together before I multiply. So I would want to multiply this top and bottom by 4 to get a common denominator. So 48/4 plus 21/4. Let's see, that's going to be 69/4, but then times a half is going to be 69/8. So that's going to be my approximation for my area. And it is just an approximation. So if you looked at our formula at the top, it said the area was approximately equal to, and that's because we know we're just adding a bunch of rectangles. It's not going to be perfect. And so as we keep going in math, we're going to figure out how to find that exact value using calculus. So hopefully this was helpful for you on problem 63.